Good evening, everyone. I'm Siddha. Before to explain about my new topic on data structures, that is on the implement of the single linked list. So, as coming to the experiment, we implement the following experiment using the class and node concept as a class and object concept. So, in the public parameter, we are going to defines initially some of the important factors necessary to execution of the single linked list, and here we define another class, that is a list from which the elements of the public class are being inherited using the resolution. And now we can here are some of the important functions which execute the linked list operations of linked list, that is void, create, insert, delete, display, and search. So while elucidating some of the functions, in from create function enables us to create a new linked list. If the first element is not equal to null, then the while list linked list is implemented, or else the last is equal to 10. So here comes our insert function. So insertion can be done in many ways in linked list, that is from first, from last, or in the middle of the nodes. So here we're defining start, previous, start, current. These are the types of pointers in which we can store the addresses of the respective nodes. So here we can here I define some of the important parameters as count, position, character, and integer, that is a number. So here we can insert the element in three ways, that is the first node, the last node, and between the nodes. So if we here we can implement these three using the switch case. So if case 1, that is as a first node, then a temporary factor of the temp next is equal to first, then it gets implemented. So if we click second case, this is last node, the last arrow next is should be equal to temp. This is case 3, that is it's a position in between first and last node. So we are not aware of the number of nodes in the linked list, so we have to enter the position to where we can insert. So if the count is not equal to the position, then the monkey factor jumps from one node to another node. If the count is equal to position, then the perfect is the element is being inserted, or else the position is not detected. So in delete also same way, we could delete in first node, last node, or between the first and last nodes. So if we do step implement it as a switch case, so if in case 1, if the first is not equal to null, then the deleted element is so and so, or else the limit is not able to delete. So case 2, that is last node, if current is not equal to last, so previous is called current, and current is called current arrow next. So if current is equal to last, then the deleted element is deleted element is current arrow info, that is a deleted element, or else the position is not determined to delete the element. So now in case 3, that is we can enter the position of deletion in between the linked list. So if the count is not equal to position, then the monkey factor jumps from one node to another node up to where till until the node arrives. So if count is equal to position, the element is being deleted, or else the position is not able to detect it. So display factor enables us to see the number of elements present in the linked list. So here we can define start temp, where we can store the address of the temporary variable. So if the temp is equal to null, then the list is empty. If temp is not equal to null, then the total number of elements in the linked list will be displayed. So enter the search algorithm describes us to search the perfect element present in the specific position, etc. So if the first is equal to null, the list is empty, or else we have to enter the value to be searched. If the cn of value, if the temp is not equal to null, the position is being increased, and the value which we aspired for, we can get it. So if temp arrow info is equal to value, then flag is equal to true, that is element is present and the element found at the position is being detected. If it's not equal to flag, that is flag is equal to 0, then the value is not found in the list. So it comes our main function, and we are going to execute the create, insert, delete, and all search and display, that is specific operations of linked list using a switch algorithm. That is a case 1 of create, case 2 is insert, case 3 is delete, case 4 is search, case 5 is display. So now here comes the end of experiment, and we can see its execution. So here comes our output table, so that our experiment is free of syntax errors. So now I will create an linked list, that is I will enter the element 3. So how the linked list is created, so I will insert another element, that is 6. So it asks the options, so I'll enter it as last node. Again I'll insert an element, that is of number not 6, it's 9. I'll insert is a first node, and now I want to I want to search an element, so I'll use I will letter 6. So it's found at third position, that's right. So and now I'm going to display the elements present in it. So here this is the display, this is the linked list 9 3 6 etc. So now I'm going to delete an element. I think I'll delete the first node. So the deleted element is 9, as here the 9 is the first thing. Now again I'll enter the element. I'll enter in between the first and last nodes etc. So here comes the end of the experiment, and successfully our output is being verified. Thank you.